All right, so it looks like we have a solid group with us right now, so let us get started. We are excited to have you with us today as we unpack the significant changes introduced in the 2024 Ontario Building Code related to interconnected floor spaces and floor openings. Today we have Jack who will be presenting on behalf of Vortex Fire Consulting, Inc. Jack is a seasoned fire safety engineer and building code consultant with well over 20 years of experience. He has presented at international conferences, published articles on fire safety, and served on several committees developing building code standards. His experience spans from design to construction, helping teams find smart code compliant solutions to complex challenges. Please join me in welcoming Jack Keys. Jack, the floor is all yours.
Okay, hi everyone. Great to see you all again today for part two of the installment in our deep dive into various code changes. Today's presentation is on interconnected floor spaces. This has been probably the part of the code that's been the most overhauled. It's really a really big change from what we would have been doing before in Ontario. We're going to talk about that today. We're actually going to take an exemplar building of a 4-story office building and say how this would have looked under the old OBC, under the 2012 edition, and compare that to how it now looks under the 2024 edition. For people who are joining who work outside of Ontario, definitely when we work in Toronto, we're going to be a bit of a bubble, but these requirements have been in place in the rest of Canada for a long, long time. So it's not something we haven't worked with before, but it is a big change in terms of how we would work normally in Ontario. As I said, it's quite a large change in how interconnected floor spaces and floor openings are addressed. So in terms of prior to the recent code change, Ontario had a very specific approach to how it addressed interconnected floor spaces. It was not something I'd ever seen anywhere else in the world. In all the different codes and standards, Ontario had its own way of doing it. The National Building Code of Canada has its own way of doing it. And when we work on international projects like under NFPA or in the Middle East or wherever, they have a very, I would say, probably a more developed approach to actually how you deal with interconnected floor spaces and atriums. Hopefully we might be able to use some of those approaches in alternative solutions because I think some of these buildings are going to need it. But in terms of where the code is right now, the OBC has just pretty much en bloc taken the National Building Code and said, hey, Ontario, you're now going to do what the National Building Code says, and it's part of the ongoing harmonization between across all the provinces. So the Made in Ontario requirements are pretty much gone out of the OBC as it pertains to interconnected floor spaces. With that said, there has been some good changes. It's not all doom and gloom, or it's not all major changes. One of the big changes or good changes we've seen is Ontario previously had some very specific requirements around schools, notably elementary and secondary schools, where we had to do additional separation. Even if we were allowed to have an interconnected floor space, we still had to put a smoke separation essentially on the second floor. This meant we had to do solid glass and solid and different things around stair openings and that in 2-story schools. That actually has just gone out of the OBC now. It's just no longer there. It was never in the NBC. So it's just taken out, simply not a requirement anymore. It's often funny when you see these things that just leave the code. The challenges we would have had in the past trying to address them by alternative solution and that, and just, with a swipe of a pen, they're essentially gone out of the code. So this is the example of what a school would have had to do previously. It's a pretty basic sketch, but essentially if you had a 2-story school, you would have had to put a separation on the second floor. It could be either smoke or fire rated, depending on its location, but it would have been a requirement. Now we're free to actually interconnect those in the same way we would do any type of building, whether it's a school, office, things like that. That interconnection requirement has gone away. So that's just on the very front end of what's changed. We're going to go through some of the exceptions here because there have been some nuanced changes within this. It's important to understand them, especially if you deal in larger, I would say, industrial buildings, or we would have seen actually some of these issues come up in rail facilities, things like that. So this is an exception here. Under previously we had 3282, which is exceptions to special protections. It had 5 sentences. One of the changes, they've actually shortened it down now. They've made it shorter, which is good. And they've got very specific in here. They're no longer sending you around the code as much. They're going straight in on it and saying, hey, if you want to be exempted from these special protections, this is what's required. One of the changes I'll just do it to show you here in this table. One of the key changes is in the first 2 sentences, it's the same, no real change in that. But what is different here is now a mezzanine. If your mezzanine exceeds 500 square meters, you're now going to have to fire separate that mezzanine, even if it's not considered a story. So that it has ramifications in that previously we wouldn't have had to do that. We could have gone over those requirements at a 500 square meter mezzanine. If it was not a story, I wouldn't call it a loophole, but there was a way to navigate through the code to get back around. So that's no longer there. But what it also does mean, if you have to introduce this fire separation, you lose the ability to view the floor below. So you probably won't meet the classification of a mezzanine anymore anyway. So it's a bit of a cycle to go through it, but it's got some nuanced changes if you're hoping or planning to do a larger mezzanine. As I said, we often saw these in like GO Transit rail facilities where we had mezzanines of this scale. Don't see them too often in regular offices and things like that because it is pretty big, but it does have a ramification in terms of it could potentially change the height of a building. If you were dealing with an industrial building, say, now that building may have once been 1 story. Now, actually, with this change in separation requirements, it could end up triggering it to be a 2 story building, or if you had a 2 story building, it might make a 3 story building because that mezzanine level is actually coming around and making it turning it into a story. So that's one to be careful with. It is a nuanced change. As I said, we don't see it too often, but it is something to watch out for. So this is the example. This is just showing it. Whereas now the fire separation arrives in. Previously, we could do this. Sorry, we could still do this, but now once it goes over 500 square meters, you will be required to separate it. Okay, so one of the other exceptions that's always been in the code is the exception to have a 10 square meter opening in a floor assembly. That's taking you from, say, for example, if you're in an office building, a very common feature we would see is to have a communicating stair. This requirement has been maintained. However, they've made I'm going to call it very annoying. I have no idea why they did this, but they've actually taken out the word stair out of the sentence. So a stair is no longer included in the exceptions for an opening between floors. So if you want to have a communicating stairs, believe it or not, you're actually allowed to have an escalator between 2 floors or an inclined moving walkway, but you're not specifically required to have a stair. So this, for a lot of the projects we would be doing, it would be a very common feature in interior fit outs, in tenant improvements, tenants taking over spaces, especially if you want to take in multiple floors, part of their, just day-to-day communicating, walking between floors. It's unfortunately taken out. So this is the exception that would have been in the building code. There are some areas where it's still allowed in terms of in non-sprinkler conditions, believe it or not. But in actual typical high-rise office that we would see a downtown office building or wherever it is, this exception has been removed. I think this is one where we're going to see probably having to do alternative solutions now, either to apply the requirements that would have been applicable to an escalator. I don't see why an escalator would be treated differently from a stair. From a fire spread perspective, there's no reason I can think of. If the escalator is not moving or is broken down for whatever reason, it is essentially a stair. So I don't see why that would change. But this is one where an as of right situation has been removed and this has been brought into the code. So that's just one to watch out for if you're doing your designs. The other thing is it keeps it 10 square meters. Typically in Ontario, or not in particular in Toronto, in other cities, we often went up to 20 square meters. That was based on some building code commission hearings from, I think, the 90s. So we'll see if that can be used to also increase the size beyond the 10 square meters to get it closer to 20, which is probably what's needed to fit the stair designs we want to have through the floors. Okay, so that is one change. One of the other changes that's happened, and this has always been in the code as well, has got to do with the connection of level 1 and 2 of buildings. So you'll see this there's some wording changes in this, but essentially this is the same in terms of you're still allowed connect one floor up and one floor down. Either not more than two connected, but it can be either the basement or the floor above. What has changed though within it is that there's now a new provision to allow an unsprinkled condition. We'll go into that in a second. And the interconnected floors have to be sprinkled. That's another change in terms of the whole building. Sorry, only the interconnected floors in this, but it is a change in terms of what's allowed. So current status, this is what we would have been doing, which we allowing two floors. So that hasn't changed. What has changed and is here is got to do with there's now a provision to allow an unsprinkled stair connection just for stair openings. Escalators are moving walkways between level 1 and 2 only. You can't use this higher up in the building, for example, but it is allowed now in an unsprinkled condition. There are caveats on that. One of the caveats is that the actual building area can't be more than half of the construction or the construction article or the building area. There's a bit of work in terms of actually assessing whether you're allowed to do it or not, but it's an actual relaxation. Previously, we weren't allowed to have these stair openings between floors that weren't sprinkling. So this is a relaxation to match the Ontario Building Code up with the National Building Code. So a change, not too often. Realistically, most of the buildings we actually work on are sprinkled already, so it's not the biggest deal for us, but it is in there in case you're dealing with a smaller office potentially that wouldn't need to be sprinkled at a lower number of stories. Kind of they max out the sprinkling comes in at 4, 5, 6 story levels anyway. Um, Another change that's happened is the code has got very specific about when draft stops are required. So it's actually not in the interconnected floor space section, it's back in 325, but it states that you only have to provide baffles and draft stops essentially around the openings where the code asks you to put them, where the actual Ontario Building Code asks you to put them. There's often in the past been ambiguity around for example, does NFPA 13 supersede the OBC or the NBC, different things. So now it's very clear. If the code doesn't say you need a draft stop, then you don't need to provide one. So for example, in the two-story interconnections on level 1 and 2, the code actually quite clearly states now you don't need to put baffles on those openings. Same for stairs. If you have a stair opening, you're allowed to connect those in level 1 and 2 when it's sprinkled like this. That's a good thing, I think, in terms of actual, there's always often challenges with headroom clearances, different things around those. So it's something that will help designers out and help with actual implementing these strategies. But it's something to be aware of that the code has now gone very specific on this, which is a good thing. Okay. Okay, so we're going to start in now to what is essentially the biggest part of this actual presentation. And what we're going to do is we're going to walk through the various changes to the building code. And this has been I mentioned this being a major overhaul. I'm going to say in terms of design, the good old days are behind us in terms of how simplified the OBC was. This actually has a lot more work required for designers in how you implement the strategy in the building. It's especially in lower buildings. The OBC had a lot of these requirements before, but they only kicked in at 18 meters and at times at 75 meters. So this was something that it did have, but now in the exemplar building, we'll do a comparison between a 4-story office building under the 2012 OBC and under the 2024 OBC. It's some of the feedback we got from the last presentation was, hey, can we get specific or get more into details on this? So that's one of the things you'll see today. We have gone into some detail. So this is an example of our exemplar building, very basic layout. This actually is based on a building we have constructed in the GTA, but we decided not to put the floor plans up. So this shows you example building, just a very simple building, 4 stories interconnected, one floor opening. And this is the changes, or how it would, if we had to design this right now, how different this would look, because it would look quite different. It would not be the same design approach. It would not be the same questions we'd be asking. It would be not the same items we would be submitting to the city for approval, because it is changed. Okay, so this is the new requirements. They actually fit nicely in here in two snippets from the code. But believe it or not, there's actually a lot of meat and potatoes in these two, in terms of how we actually implement them and what they mean for design. So let's just start off with some of the easier ones. One of these is on sprinklering. Sprinklers were always required in an interconnected floor space. However, now the code has actually changed where it doesn't say the interconnected floor space has to be sprinklered. It says that the entire building has to be sprinklered. It's not as simple as that. The code actually previously said it was the interconnected floors and the floors below, but now it's actually expanded that to the entire building. It's got, as I mentioned, it's got very specific around closed space sprinklers and draft stops. It's taken out some of the references to water flow alarms and supervision, because they are actually picked up in other parts of the code. So that's not such a challenge anymore, because previously, for example, you may not have needed a fire alarm in a building that was sprinklered, whereas now you do. So some of these have already been picked up in other code changes, so they're just taken out. So the actual interconnected floor space on sprinklers is simplified somewhat, but it is also bringing up that the entire building would need to be sprinklered. So with that said, let's go to our exemplar building. This shows a very basic example of it, but previously under the 2012 OBC, we would have been allowed to just sprinkler the interconnected floors, 3 floors, so we weren't under the exemption. And then we 3 floors with a sprinkler. We would have, if we wanted to, been allowed to actually leave that unsprinkled, whereas the 2024 just comes straight in and says, yeah, you have to do the entire building now if you want to go under the interconnected floor space provisions. Not a very common thing we would have seen, but it is there. Just be aware of it, that we can't just do the interconnected floors anymore. So one of the things that's no longer required, and I'm quite happy to see this go out, but it's basically anyone who'd worked in Ontario would have been familiar with the cylinder requirement, such that, and it makes a lot, in terms of actual smoke flow and fluid dynamics, it does make a lot of sense that if you want to get air, if you want to pull the smoke out of the top of an atrium or an interconnected floor, you should align the floor such you're not getting too much going over and back. Every time you pull the smoke plume over and back, it actually it expands out and actually travels more. So you want to try and keep it as contained as possible. But this cylinder requirement has gone. What I would say, this is an exaggerated example, because I don't think we'd realistically see something like this. But what's interesting is we had previously had to do a number of alternative solutions around the shape of an atrium. That cylinder, for example, if we had an atrium that was narrower at one end and expanded out, or didn't quite fit the cylinder in terms of its shape, because at times the cylinder had to be 6 to 9 meters wide. We didn't always have that amount of space in there. Sometimes we had narrower ones. I know some projects we did in Ottawa, they were narrower. And then same with in GTA, some of those were just different configurations. So this requirement is no longer there. So this is some freeing up for designers in terms of how you actually can configure your atrium. You are essentially allowed to do it any way you want. From a fire engineering perspective, it actually potentially reduces the performance of the building. If you try to actually model this in a real 3D model, you would get pretty bad results on because the code doesn't tell you to do anything. But that's the kind of interesting thing about the code. If you follow the actual OBC, you don't have to prove anything. It just is accepted as being good enough. So that is what you can do as a designer. So you can follow any of these to get a reasonable approach, or get an approach that meets the OBC. Okay, so now we're into some of the bigger changes. Previously, some of these were applicable with buildings over 18 meters, so they had times when we would have been doing them. A lot of times our buildings where we had interconnected floors, they actually were in the lower floors. We didn't exceed the actual height, didn't go over 18 meters. It was usually the lower floors, so we were able to exempt ourselves from some of them. So the first one is we're going to talk about these in more detail, but we have smoke control. We now have to provide, for example, pressurized vestibules to the staircases. Previously, that was a higher building requirement. In terms of vestibule design, we also potentially have to do elevators. But the biggest one is probably on the exiting. How exiting is approached under the new OBC in interconnected floors. That's the one I would see having the biggest architectural change to how we design and how we build buildings. So, for example, we give our exemplar building on the left, the 2012 OBC. We have our new 2024 building. So, as a simple one, it might look like a big deal, but we now have to actually put a vestibule, no matter what height the building is, in front of the exits there. That vestibule has to be 1.8 meters in length. Between the doors, measure between the doors, it gives a specific dimension, and has to be provided on any story in the interconnected floor. So this goes into the same thing. So you'll see here, this is an example. We show our exits on plan. You'll see the plus. The plus indicates that we've pressurized those. And then you have your vestibules here. So this doesn't look like too big of a change just now in terms of it's taking up space, it's taking up real estate, it's taking up space that you could use for probably some other purposes, but it's not that big of a change yet until you get into more detailed exiting analysis. So this is an example of the elevator. There's now a requirement as well to protect the elevators if they open into floors above. If all the elevators are within the interconnected floor space, you don't have to do anything with them. But this is something that you would see come up potentially if you're not interconnecting all the floors. So this is an example of what would happen if you have, for example, a 4-story interconnection and you had more floors above. You've got two options as a designer. One is to put a vestibule on the floors within the interconnected floor space, or alternatively, you can do it on the floors above, depending on it's a designer's choice. For example, these gives you two examples here. In terms of our reference building would have had no change to this. The reason our reference building has no changes is because we do not have a floor above. So there's no requirement to add vestibules to the elevators in this configuration. So that is a change. Just be careful just in terms of knowing that if we do an interconnected floor space and we have floors above, we got to figure out how we're going to do it. Simple example, if you've got an interconnected floor space of 4 floors and you have 50 floors above, you're probably going to do the vestibules in the actual interconnected floor space. If it's just 1 floor above, it makes sense to do it on the floors above. So that comes down to it's good. It does give at least the designers some choice and something other than a prescriptive requirement. Okay, so exiting. This is where it gets a lot trickier and a lot more complicated. A few things is previously you had to do these requirements in buildings that were over 18 meters, so 4 or 5 stories. For example, the new St. Lawrence Market North, for example, that building would have just come in a whisker underneath the height, therefore didn't have to do cumulative exiting. If that building, for example, had to do cumulative exiting, it would have significantly changed the actual fire and life safety approach and would probably have architecturally changed some of the layout. And one of the requirements is that you have to either provide sufficient sized stairs, cumulative exiting. These are things that we'll get into in a bit more detail as we work through some calculations. But one of the things that has gone away out of the OBC and is a nice change is previously we were limited on travel distance in the OBC. We had to use the unsprintered conditions, even if the building was sprintered. So, for example, assembly occupancies would have gone down to 30 meters and 40 meters in offices, whereas now we're allowed to have the 45-meter sprintered condition. There has been no change it's increased the travel distance within an interconnected floor space. So let's talk about the egress options because none of them are particularly easy. There's essentially 3 different options. You make the staircases big enough to cumulative exiting. You actually have sufficient space in them as a second option to allow for everyone to assemble. Or the third option is you do protective floor areas. We're going to work through them. I have a feeling which ones we're probably going to see more of rather than less of, because I don't think some of them are particularly practical in the types of buildings we would work on, or most of our architects would work on. So we'll get into the details. So this is the first example. This is the example of cumulative exiting. Essentially, what it means is that as you come down the building, every occupant load you pick up, you have to expand out the stairs to allow for that occupant load. So if you have 70 on the top floor, sure, an 1100 millimeter staircase will be okay. You pick up another 70 on the second from top. You'll be just under. So we'll just say 11, just slightly over 1100 millimeters will be okay. But now you pick up the next occupant load on level 3, and you have to gradually increase the width of that stair as you go down to allow for cumulative exiting. This isn't a very practical approach in terms of how I've sketched it here. It just simply can't make an exit wider and wider in terms of structurally everything. It's just not the most practical approach. We could see an approach to this where what we could end up seeing is like, hey, on level 3 and 4, we have an exit stair to go straight down. And then as it comes down, we may pick up another stairwell on 2 that serves level 2. And that then might allow us to do it in a more vertical arrangement where we have staircases that don't go the full way up through the building. And that could be a way of addressing the cumulative occupant load. But in terms of, and it might be actually the best approach when you see some of the other challenges with some of the other requirements. Maybe if you have the ability to do it in a 4-story building, that lower, I think lower heights, you might be able to do this. It could be an actual way of dealing with the egress from the building. Essentially, under the new NBC provision, the code wants you to get everyone out at the same time from the interconnected floor space. We'll talk about it, but like for example, the smoke control systems in the new building code are not automatic anymore, meaning they won't turn on for at least the fire department kind of 10-minute response time you'd be looking at in the GTA. That means people are probably either significantly out of the building or egressing from the building when the fire department arrive. There's no active intervention of the smoke control system, so it's one of the key things that the cumulative exiting has to be allowed for. So this is one of the cumulative exiting approaches. I go back to our current OBC. If we'd built if we'd built an office building or an assembly building or any kind of building with an interconnected floors over beyond the exemption, so over 2 floors, we would have just been doing regular exiting at this height. We would have not had to do any of this under the current OBC. So that would be a significant change in terms of how we address exiting. If we'd had to do this, and I can think of a few different buildings around the GTA that would have had different design approaches had this been in place. So the next option is that the code allows you to allow enough space within the stairwell such that you can accommodate everyone from the floor. So when we actually go and look at this, we say, okay, roughly how big is our stairwell? It tells us we can allow 0.3 square meters per person. So a rough order of magnitude on a stairwell is just under 14 square meters. We divide that by our per person value of 0.3 meters squared per person, and we get an occupant load that could be accommodated. And this is a regular size stair we would have seen. It would have been 46 occupants we can take in each. That is 92 people potentially on a floor. That's not a lot of people in terms of floors we typically work on will be much more heavier loading on them than 92, simply just not enough. So what happens to the rest? So when we have to look at what happens to the rest, you're going to have to start, if you want to take this 0.3 square meters per person, what you'd have to actually do is increase the size of the landings. It's the only real opportunity you have, such that you create enough waiting area within the stairwell. I'd like to point out that this is beyond the vestibule. So you come through the vestibule, you come into this area here, and you actually wait in there to egress from the building or gradually trickle into the stairwell. So for example, we mentioned that if we had 240 people on the floor, typical occupant load we would have seen before, we would need a total area of 72 square meters. We have our stairwells taken out here with the roughly 28 square meters. So we would need an additional 44 square meters, which would have to be 22 in each one. So that is a significant amount of space to just take off a floor area. no, it's not usable, can't be used for anything, you can't occupy it, you can't store in it, you can't do anything in it. It's just essentially increasing the size of the stairwell. So that's something to be careful with. If you go with that approach, this could be a good approach if you have lower occupant load floors. So maybe if you're dealing with a building that, for whatever reason, is maybe it's a small footprint, the building itself, or just a low occupant load for whatever reason, this approach could be, we actually just use the stairwell itself. We get 92 people on the floor. That could be something we could do. If you're looking at higher occupant loads, you're going to gradually increase this to be a much bigger area. So that's one of the reasons I think it's going to be challenging with higher occupant loads. So what's the next option? So if we don't want to do cumulative, then you don't want to do providing enough space in the stairwells themselves. The third option, and it's probably something we think is probably going to be the preferred option, is actually protected floor areas. So what a protected floor area is that it essentially is a place of immediate safety. So if there's a fire spreading up through the floor openings, there's no smoke control turning on because we now don't turn it on automatically. The occupants of that floor can immediately move to another area on the floor. In that area, they're able to wait as they gradually enter the stairwells and exit the building. All the stairwells, bear in mind, now are protected. They have either a protected vestibule or they're in a protected floor area. So they're considered to be protected to allow you exit the building. With this, you still have to provide vestibules across. So this separation here, it's going to be the same as a floor area. So it depends on what the floor rating is. But for example, if this is a 1 hour building, it'd be 1 hour. If it's a 2 hour building, it's 2 hours. And then you still have to put the smoke control vestibules in, pressurized vestibules here to keep smoke on the interconnected floor area side. And then you have to size this such that it is 0.5 square meters per person. They've increased the size over what would have been allowed in the stairwells. So that's an example of how it would have to be designed. Bear in mind when we go back to our previous design or how we would have previously designed interconnected floor spaces, we would have been able to just walk straight in here, go straight into the stairwell. We would not have had any of this. So it's a big change in terms of if you were planning to have a totally open floor plan and an interconnected floor space, this is going to change it such that some of the space has to be fire separated from the interconnected floor. Depending on how your floor is arranged, it may not be that big of a deal. If you have, for example, areas around an opening, but however you have other offices that are away from it or different things like that, we might be able to incorporate this without too much change to the design. It may mean we have to incorporate some doors and corridors and get some fire separations in, but it may be not that bad. But if you were actually planning to have a totally open plan office and you want to do this, this is a change that's going to change the actual way you design that space. So this is an example. We talk about a very simple calculation of how much area you need to have. You have a floor area of 240 people. It's essentially half of that because it's 0.5 square meters per person. So it comes out at 120 square meters. Shouldn't be that hard to actually meet. We could also potentially end up meeting, as I said, with corridors, things like that. But that space can be used. You can have this, for example, this can be office there. This is not dedicated space. This could be totally usable. You just have to make sure you have enough space back here in the circulation and that to accommodate everyone who's coming across. So that's one of the design approaches we think will probably be easier in some applications, not all, but in general, it can allow a way or a methodology for to actually implement some of these that are a bit easier. Okay. So that is the end of the kind of the egress part. As I've noted, it's not easy. It's going to be a significant change. It's going to take some thinking at the very end of a project. Realistically, if someone sends us a set of drawings that are pretty advanced, they're going to get some comments back if they haven't thought about this, and that will actually impact their design. So I think some early intervention here or early discussions around what the strategy is going to be, what the impacts it means, Like, for example, if you have a 4-story building, it might make sense just to do an extra stairwell on level 1 and 2. It might be something that could be accommodated easier than trying to actually do these other measures on the other floors. So these are costing exercises as well that would have to be considered. Okay, so now we're moving on to some of the details. Not sure why they've done this, but the new code has been updated. It now requires, I mentioned that it got very, very specific about draft stops, for example. In the draft stops, it's now increased the depth of them. So this is actually something designers, please watch out for this. You do not want to have a nice, beautiful glass installation in place, and we all discover that it's 50 millimeters short. These have been increased when you have them. So that is a change in the OBC comparative to what the old one was. The old one was just based on NFPA 13. Which would have a 450 millimeters. So I mentioned it has increased it by 50 millimeters. This is where the change has happened, just at the just here between the floors. Another change that's happened is that in terms of mechanical exhaust, the OBC just now requires 4 air changes. Previously, we had an approach where it depended on the volume. So if you had a larger volume, you did 4, and if you had a smaller volume, you did 6. That actually makes more sense in terms of actual how smoke behaves. We'll talk about it in a potential alternative solution application at the end. But typically, when you have more, the bigger the volume, the more actual dilution can happen, the more space you have to allow smoke to backfill. So it would make sense that you could reduce the exhaust rate with a higher volume. And then in the smaller spaces, when you don't have all that dilution air, you increase it up to 6 air changes. Now, whatever about that, that's kind of fire dynamics change. One of the changes that's quite different is previously when we had a smoke control system, we automatically started it. It activated off smoke detectors around the openings. So if one of those smoke detectors picked up that there was smoke in the building, it would automatically turn on the smoke control system. That is no longer the case. If you want to turn on the smoke control system now, the only people who will be turning that on are the fire department. Even the building management aren't going to turn it on. It's very clear that it's for the responding firefighters. So when the responding firefighters get to the annunciator panel, it should have controls beside it that turns on the mechanical smoke control system. If they deem it necessary, it's going to be their decision to turn it on or not. That is quite a change because I mentioned the 10 minutes. We talk about egress times and that a lot of these buildings would have had at least exhaust happening before the fire department arrived. Now it's no longer going to be the case. And GTA, 10 minutes is the ideal time. It could be longer than that. So it's probably, in my opinion, a reduction in performance comparative to what the current code would have allowed. Okay, so the next one is on combustible contents. And we talk about the devil being in the details, but the devil is definitely in the details on this one. So previously, we had no limitation on what we did within the interconnected floor space. If it was an office, it was nothing to say that we had to limit fuel load. If it was an assembly space, there was nothing to say, for example, we couldn't have as many tables or desks or bookshelves as we wanted, as long as there was no limitation whatsoever. With the new code requirements, and this is why when we often see code changes, they're a suite of code changes. So while it's taken away the automation of the smoke exhaust system, it's now brought in a different control measure, and the different control measure is on combustible contents. So anywhere where the height of the ceiling is more than 8 meters, there's a limitation on the combustible contents. This does not apply in the areas where it's less than 8 meters. So if you're underneath the floor slab here, you're good, not included. But if you're in here in the red area, that's where you now have a limitation on combustible content. And the limitation is 16 grams per meter cubed. So I'm sure when all of the people on this call were going to architecture school or whatever schools they went to, they probably didn't do calculations on combustible content. So it's going to be a new facet that's going to have to be included, or limitations put on the actual use of the space. So we go back to our exemplar building. Previously, we had no restriction. Now we now have this requirement. We're going to actually get into a little calculation on this because I think people need to understand what it means. So we talked about what's limited here. So we have to go in here and look here. So we look at what we have to do is calculate the volume of the building. So we just already interconnect the floors. So we just took an 80 meter by 50 meter building, and it's 16 meters high, roughly 4 stories. So we get 64,000 square meters of volume. In terms of, we now multiply it by our grams per meter cubed, and it comes out to just over 1,000 kg, so just over 1 ton of combustible material. Now, depending on how your interconnected floor space is going to be arranged, if you're planning to have a very large area with the full height space, this actually isn't a lot of material potentially. So if you go to example, I tried to just pull out some examples to give people kind of order of magnitude on this, and it is, just bear in mind, this is combustible content. And where I go with that is, if you have a couch, for example, and you have a couch that contains foam and plastic and that, however, the frame of the couch is metal, the actual full weight shouldn't be considered. It should only be the contribution of the combustible material. So there's going to be some judgment have to be made there on that. In terms of wood tables would pretty much be 100% combustible. So you'd be looking at 90 to 100 kgs, depending on the size of them. So we go back to our and bookshelves are actually one that really take up, they really add to the weight as well. They're kind of 60 kgs per linear meter is the order of magnitude on those as well. So if you have this situation and you were hoping to, for example, in a school setting or a university setting, it would really limit what type of furniture you could put in there. It would limit the use of the combustible materials such as wood. For example, if you had a few bookshelves, 10 or 20 meters in length of bookshelf would eat up your combustible allowance pretty quick. We're allowed 1 ton, so that could be 5 couches, 5 tables, things like that. So there is a bit of work to be done there on actually making sure you don't exceed those amounts, or arranging it in such a way, or actually selecting furnitures and that allow you to have what you want in there. But not a huge fan of this limitation personally. I think we have dealt with it a few times on a true alternative solution and adding other measures. The other thing that kind of worries me also is just the lifetime of the building, how enforceable this will be, how it will change over time. 10, 15 years down the road, will anyone ever remember why there was a limitation on the furniture? It may or may not get included in the fire code. So it's going to be one of those things where we have to watch out for, but it is in the code in terms of when we show this, if we're showing furniture, the furniture should not exceed this amount. I haven't seen anything yet about adding signage or anything like that in terms of fuel load. Again, it would be a hard one for people. Most people wouldn't understand what it means. So it's a challenge, but anyway, it's in the code. There's nothing we can do about it. It's also, it's just a bit more of a challenge for the designers in specifying what we want to do. In terms of these requirements that I mentioned have been around Canada for a long time. They're just new to Ontario. So we have dealt with a few different alternative solutions over the past while. For example, the new Stanley Miller Library in Edmonton would have been some pretty big alternative solutions on that to address the bookshelves that I mentioned. Wouldn't be much of a library if it didn't have bookshelves. So one of the other ones we've all done in the past is looked at the protected floor areas. Instead of actually providing the vestibules here, we've looked at solutions where we just pressurize up the whole area. Just give us a cleaner look. We didn't want to have, in terms of communicating spaces, we just didn't want to have the vestibules here. They do interrupt the communication across the floor. There was no natural divide. So one of the things that happened on that one was to actually just do this solution where we just pressurized up the entire area. So we just ended up with one set of doors, a bit more streamlined, still not probably as good as they wanted, but it did allow us to somewhat streamline it. So that was done through alternative solution under the Alberta Building Code. Anything obviously you do with an alternative solution takes a bit of work, takes a jurisdiction that understands it. And the jurisdiction is willing to kind of look at alternative solutions. So that was a pretty positive outcome on that one on a pretty complicated project. This is another one. I mentioned that the code just doesn't really consider the geometry of the building. And where I go with this is, it's a very simple analysis. If you have a high ceiling, essentially what it means is there's just more space for smoke to build up. So the smoke can hit the ceiling or the roof, it backfills. And it comes down to roughly ceiling head height here. So once it drops below approximately 2 meters, it's considered to be in, impact egress. So if you have a low ceiling height space, for example, you could lose tenability very quick. If you have a very high ceiling space with just physically more space for the smoke to go and build up, gives you more time to get out. The code doesn't consider that in any way, shape, or form. However, it's something we could look at through CFD analysis, things like that. We have looked at it in the past. We have multiple projects across Canada where we've done the CFD analysis to try and support the designs. And that could be to either streamline egress, reduce the reduce the areas in front of the stairwells, things like that. An example, if we had this building in the US under the NFPA or IBC, we wouldn't be doing a lot of these measures. We'd be potentially pressurizing the stairwells, but we wouldn't actually be doing the areas of refuge. So in terms of architecturally, it's much more streamlined. And that would, however, have to be backed up with a CFD analysis showing that you've got enough exhaust to move the smoke out. And you may move your smoke control system from from manual to automated because you really do need this thing to start up before the fire department arrive and actually get the evac or get the smoke out of the space before as people are egressing. Okay, so that's the end of the actual presentation itself. We've tried to keep these to the point. Just a few things. We got some good feedback the last day. We got some feedback that we wanted more examples. So I hope people found there was more examples in this one in terms of how it would compare with the old code and the new code. One of the good suggestions we got was one of the mechanical teams on here have come to us with hey, what about fire damper optimization? Believe it or not, it might sound like a dry topic and we may need to come up with a better title. But basically, it's looking at how interior design architecture can facilitate having to remove some of the requirements in the building code. Dampers are approximately $5,000 a pop. So if you get it wrong or don't optimize your design, it potentially has a big impact over the course of an entire building. So that's one that's come to us. Just a few other things. As always, check out our website. We've got a lot of tools on there. Spatial separation calculators, plumbing facilities, things like that. And if you have any other topics that you might be interested in, please let us know. We got another few on the list. We're trying to see how we can implement those throughout the rest of the year. So yeah, please keep that in mind. So with that, I'm going to quickly have a look at the Q&A and see what we've got here. Just on the combustible content, no, I don't believe the IBC has combustible content. The combustible content requirement just comes straight from the NBC. I have no idea how they decided on 16 grams per cubic meter. It's probably got to do with some like how much fuel it takes to contaminate a cubic meter of air. But I don't actually know where it actually comes from. It's a very detailed requirement. And yeah, it's not linked in terms of if we were doing an analysis, yeah, we'd be looking at the fuel load, but it's a hard one to actually know where it exactly came from. So in terms of the question about interconnected floors in residential, you're not allowed to have them anyway. So you'll notice in the interconnected floors, you couldn't have an atrium like this within the Group C occupancy. So this doesn't change what would happen in high-rise residential buildings. It's going to be the same approach we'd always be taking there. It's just not. It doesn't really. This doesn't really affect residential or a hospitals because you just are not allowed to have the interconnected floors anyway. A question on can the smoke control system be automatic? Nope, it cannot. Code says it has to be it has to have be automated from being turned on from basically beside the annunciator panel. And if you think back to the old code, the actual way we initiated it was off the smoke detectors around the opening. They're no longer actually in the code as required. So that's a change as well. If you wanted to do an automatic system, you would have to do an alternative solution to make it automatic. But it's going to be a very interesting thing in Ontario. If you're arriving at the building, as a fire department, sometimes they're going to be turned on, sometimes they're not going to be turned on, sometimes we're going to have to manually go in there and do it. It's it's a bit of a different it's a different approach. So we'll see how it goes. We'll see if there's any if Ontario will modify it, but there is a big push to not modify the building code as much. So we'll see how that goes. Just a question on whether it's available. Yes. Yeah, just on the protected floor areas, yeah, you can rate those doors and you can put them on hold open devices. That's why we think they're going to be implemented probably in corridors and things like that, where we're going to hold them back to try and create the flow between the spaces. So that's what we're going to see as well in terms of trying to streamline the design as much as we can. Yes, they can put them on hold open devices, and they would only turn on, for example, pressurization would only turn on in the event of a fire. It's not day to day there. So yeah, that is allowed. Okay, just quickly checking if there's any any other questions in the chat. Seems like most people are just asking for the for the PDF. So yeah, if you have any other questions, guys, feel free as always, shoot us an email. And that we can have a look into it for you. Hope you've enjoyed today. It is quite a departure on what we were previously doing, so it's going to take us a bit of while as designers to pick up or find our optimal solutions. We've done it with every other code change they've ever made, so we're going to do it with this one as well. So yeah, thank you to everyone. And if anyone else has any questions, you can quickly pop them in the Q&A if you want, or alternatively, as I said, question: do floor finishes count? Yep, they do. Everything in that everything in that space counts. Um, everything counts, like the desk, the chair, the linings, anything you have in that space counts towards that calculation. It says you cannot, it's anything in there. So yeah, you potentially have to add in the carpet, the flooring, finished floors, whatever they are, into the combustible content. Okay, that concludes the presentation, everyone. I think the questions have finished coming in. So as I said, pop me a question, pop us an email if you have any questions, and check our website for all the tools. And with the we will be getting your certificate, and any of the further webinars we're running. We will let you know. We'll send out an email with the dates and times and who the presenters are. And if any suggestions, please let us know too. All right, thank you, everyone.